Hey, how you doing? For a good few years, we've been asked in the flat out to demonstrate how a sunrise and sunset works. I don't know what the sun is. I don't know what height it is or how big it is, but I know what causes the effect of a sunrise and sunset. The main part of the effect is optical drop, okay, which I'm going to demonstrate here now. So I'm just going to play this through. It's going to be less than a minute and a half, right? I'm going to move this through. You can see it. That's a plumb line function I'm using on the app. It makes an absolute parallel with the center of my lens is making an absolute parallel with the surface of the table. And as you can see, there's specular reflections on the table, so that means there's no warping of the table. So it's a dead straight, flat table. And I'm using just a laser, so a laser just points in a straight line. It's less than 6 foot long. The distance I'm using there is about 5.5 foot. I'm moving the whole setup is, so there can be no refraction. So there you go. That shows what would happen with a sunrise. Now the laser is not the sun, but it shows the same thing. It's the effect. If I could show it more, I would. I could show it going higher, but it's just the way the setup is. I'm just showing that there is no issue with tilt forward or back. It always comes back to 0, 0. Okay. Now I just bring it back to there. Now I'm just going to show a couple of times. Now I've made an absolute parallel with the table. As you can see, specular reflections. And the table is dead flat. This plumb bob app function, what it does is it shows, this is basically what I've shown here. There's a small little tilt to the left to right, but there's no tilt forward and back. So it's 0, 0 forward and back, but there's a small tilt left to right. As you can see, the crosshairs are slightly to the left here, but there's no tilt forward or back. If there was a tilt forward, the crosshairs would be risen and the 0, 0 wouldn't be there. If there was a tilt back, the crosshairs would be dropped and the 0, 0 wouldn't be there. Okay, so I'm making a parallel with the surface, which is what you have to do which is what causes optical drop. People on the ball side keep on focusing on the object, and I'm using a laser, which is a dead straight line. Okay, so rather than keep talking, I'm just going to show the demonstration. Okay, it's like a time lapse of a sunrise. As you can see, it's below the crosshair line. As I bring it in, it goes above the crosshair line. And I bring it back below the crosshair line. Optical drop. Back in again. Comes in, it's like sunrise, above the crosshair line. And I bring it back. It goes back below the crosshair line. And back out again. So as you can see, this is very similar to a sunset, and it's like water with the sheen off of the table. As you can see, the light is below the crosshairs, and as I bring it in, it's above the crosshairs. So just show again, bring it in, above the crosshairs, bring it back, below, bring it in, above, bring it back, below, bring it in, above, bring it back, below, bring it in, above, bring it back, below, right? And the thing about it is with this is what's the word? Sorry, I'm losing. Back in, back out. Yeah, the thing about it is with this is what it does is it proves that the main reason for a sunrise and sunset is purely optical and not the rotation of any globe out. So there you go. There's an actual demonstration for you. There's a better one coming. I'll be going to come with a better one. I was going to do this a good long time ago, but I held back on it. But there's a better one coming now. But this will do for the moment. If anyone wants to use it, you're more than welcome in your videos. Is there anything else I want to say before I go? No, plumb bob making a total parallel. I showed it. It's 0, 0. Laser, point in a straight line. Specular reflections, so there's no warping. I don't know what else to say. It is what it is. Globe debunked. Thanks.